Example 2.10. A. A 900 picofarad capacitor is charged by 100 volt battery. Figure A. How much electrostatic energy is stored by the capacitor? B. The capacitor is disconnected from the battery and connected to another 900 picofarad capacitor. Figure B. What is the electrostatic energy stored by the system? Now here, see, value of the capacitor that is given to you, capacitance is 900 picofarad and it is connected with 100 volt battery. So here we can calculate the energy stored in the capacitor by equations which we derived in the previous theory. U, that is half CV square, or we can calculate that is equal to Q square by 2C, or you can calculate by the equation half QV. See, here C and V directly given to you, so you can calculate by this equation also. But suppose you calculate first charge. So charge on the capacitor Q equal to CV. Then C into V. So charge on this capacitor, that is 9 into 10 raised to minus 8 coulomb. Here we calculate now the energy stored in the capacitor by the equation U equal to half QV. So half value of Q, this one, into V. So you will get the answer 4.5 into 10 raised to minus 6 joule. Right? Okay. Here you can calculate by substituting value of C and V here also. You will get the same answer. Right? But first we calculated Q here because it is useful to calculate the second part of this example. How? See, now the capacitor is disconnected from the battery. So when this capacitor is disconnected from the battery, at that time there is charge Q on it. And now it is connected with another same type of capacitor. So when two capacitors are of same value, then one is not charged one, another one is charged one. So distribution of charge will take place here and charge will be distributed exactly half. So when this particular capacitor is disconnected from the battery, on which charge is Q. If it is connected with the similar capacitor as shown in figure B, then charge on each one will be now Q by 2, Q by 2. So see here, first we calculate energy stored in each capacitor. So here, in steady situation, the charge on each capacitor, that will be Q by 2. So energy stored in each capacitor, suppose in capacitor 1, U1, for capacitor 2, U2. Then U1, that is equal to Q square by 2C as per that equation. Q, that is Q by 2, charge on that capacitor is Q by 2. So Q by 2 whole square upon 2C. So we can write that is Q square by 2C into 1 by 4. But Q square by 2C, that is U. So we can say that is U by 4. Now for second capacitor also the energy stored, that will be the same. So the total energy stored in this particular system. So for capacitor 1, that is U1. For capacitor 2, that is U2. So total energy stored, that is U1 plus U2. So we can write here energy stored by the system of capacitors U dash equal to U1 plus U2. But U1, that is U by 4. U2, that is also U by 4. So U by 4 plus U by 4, that is equal to U by 2. And U that we calculated here. So substitute this value of U in this equation. So you will get 4.5 into 10 raised to minus 6 by 2. So energy stored in the system of these two capacitors, that is 2.25 into 10 raised to minus 6 joule. Now the chapter 2 is completed. So next we will discuss the exercise part of this chapter. Clear?